Greetings to my fellow friend and lecturer, Professor Dr. Musa Muhammad Ahmed, will be presenting our mini project of KNR4603, High Power Transmission and Distribution, with the title Design of Digital 275 kW Step Down to 33 kW Substation from Traditional Substation to Digital Substation. Members of Group 7, Becky Vitalis Misin, Kinida Anak Midin Sumbang, as leader Desmond Liu, Julia Anak Jonathan, and Roberto Carlos.
My name is Becky, and first I will present the introduction for our case study. The future power grid will need to be able to meet the demands of an increasingly complex power generation, transmission, and distribution scenario. With cutting-edge technological advance and design, digital substation enable utilities to fulfill the needs of the modern electricity network while also mitigating the current issue. Digital substation utilize a fiber optic-based communication which decreases the installation time compared to conventional copper wire-based communication topology. This also optimizes the signal transmission rate and flexibility in communication between various equipment in the digital substation. The background of issue for our case study is related to traditional substation. A traditional substation lacks digital communication, remote monitoring and control, and consumer participation. The individual point-to-point copper connection between IEDs and primary equipment are costly, and they require significant expenditure for design, installation, testing, and commissioning. Traditional substations also use massive and bulky standalone equipment to monitor current and voltage, which demand routine maintenance for testing and calibration. Therefore, it is suggested that a digital substation is created to replace traditional substations because they have a lot of advantages other than using traditional substation for smart grid system.
We have created a traditional substation with the aid of a software called MATLAB Simulink, which has the abundant amount of copper wires used in the system, having also physical maintenance to check if the system has any malfunction. The next system we have made is the digitized substation out of the same traditional substation schematic with several changes. The most noticeable is the clean arrangement of the signal wires of each section of the system towards a single connected central station, which is able to read all of the substation data section with ease. We will be showing the components of each of the important sections of the system, which is the generation with the power supply of 275 kW to the three-phase measurement scope with the merging unit towards the central generation station, along a circuit breaker to protect the system. After that is the transformer internal design of the step-down transformer of 275 kW to 33 kW. As the requirement of the assignment and mini project. A circuit breaker before and after the transformer is placed in order to negate any incoming faults from both sides. The last section, which we will be covering the load that acts as the consumer side of the actual working system, providing feedback as what will happen to the waveform of the system with different amounts of loads. One of the analog signals taken from the project simulation to show its three-phase waveform, the other one is the digitized waveform that is converted to the merging unit that is shown in the digitized substation. As the merging unit consists of the first combination of a constant combined with the analog signals from the system, then it is again merged with a constant pulse modulator to completely turn into the final product, which is the digitized waveform. The advantages of a digital over traditional substation is that the digital version has a bus that connects all information into a single monitor, allowing easy access towards doing maintenance, unlike the traditional one which has only one monitor on each individual sections of the substation that makes identifying damaged sections harder to spot. Also, with the digitized signals, the device on the system will be able to have real-time feedback to control station, providing accurate information at any moment, while the manual reading can only be done if an engineer has done an inspection on the specific location. Even then, human errors may occur. Reducing the cost of the substation itself with optional optic fiber that has fast transferring signals from one place to another along minimal clothing. As the copper wires can only send individual signals at the same time, that means the substation requires copper wiring for each signal, which is a lot. As for the case study of the mini project, we have taken the same simulation from the assignment and provided it with some note on future improvement on the simulation if there is any individual that is interested in further continuing the mini project. Due to the MATLAB Simulink only having component assembly, the system can only be simulated in a surface level construction. Trying other software which is compatible would be suggested. The cybersecurity of the substation of IEC 61850 based system should be top priority on building a competent networking to protect the data from unwanted personnel. The calculation of costing for the change from traditional substation to digital substation would be a nice addition to the users as a strong indication to prove that digital substation has a substantial benefits. The implementation plans, which are the several research papers that had already been implemented in the past that has been studied and made into a complete documentation to be understood about the topic itself. The initial paper is the Digital Substation in Transgate, Australia, a Journey Business Case Lesson. The figure above shows the Transgate digital substation that was completed installing in 2017 that allows complete renewal of all secondary systems within the substation. Designing process is highlighted in the research paper as it factors the cost of the entire system, with enhancement of additional low-power instrument transformers that improve the integration of switchgear that will lead to a full virtual system which is simpler to maintain. Next is the digital substation on case study of Tata Power. It covers the IEC 61850 in the relays of the substation, which requires specific application initially to define the message matrix to be created. Any errors of misdirection on the file will result in interlocking of the relay that loses communication with the message service on the mapping. The paper pressed on that the digital substation had drastically reduced the costing with much higher rate in management and maintenance along in reducing the reliability on hardware cabling logistics. The final research paper, which is the effectiveness and comparison of digital substation over conventional substations. The last research paper has been informed that using the IEC 6185 substation architecture as shown in the above will reduce energy losses, since the system has stable instant feedback to the central control station with a higher rate efficiency. That is done with optimizing network configuration that allows better service to communicate with the clients.
The implementation of digital substation not only reduces the capital cost of building substation but also reducing the cost of ownership over the lifetime of the substation. Implementing a digital system in parallel with a conventional protection and control system was necessary to evaluate and compare the performance between the systems. This project is a first step beyond studies to understand and realizing the practical benefit from the design process to implementation and maintenance. The requirement to repair all of the substation damaged copper line presented a chance to consider fiber installation. The analysis demonstrated that fiber is a cost-effective solution that offers all of the advantages of using fiber rather than discrete pair of copper control wire for each control and monitoring function. This is not available via traditional copper cable methods. The digital substation gives operational, maintenance, and engineering workers far more measured and computed information on the power system that was previously available. Rapid advancement in electronic technology, along with higher system stability, expanded communication bandwidth, and improved system performance, will make implementing digital technology a safe and cost-effective alternative.